Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 8.3, Vertex form of a quadratic equation. And today we're going to learn a new form of a quadratic equation. Similar to how linear equations, there was, just put them over here, just as a review for a moment. There was slope-intercept. There was standard form, and there was point slope. These are all linear equations, okay? Now we have quadratic equations, and we have standard form, which is what we saw previously, ax squared plus bx plus c. And then there's vertex form. And vertex form is what we're going to learn today. And each one of these, just like in linear equations, slope-intercept was really easy to graph. Standard form is really easy to use to find the x and y intercepts. And point slope is really easy to graph as well. Standard form is easier to factor in quadratics. And we factored trinomials, and we'll do that in quadratics as well. And vertex form is easier to graph. And so you're going to see that today, especially after the last lesson where we graphed. You'll notice how much easier it is, how much quicker it is to graph these. All right. So vertex form of a quadratic. What is the formula? All right. Well, the formula is y equals a times x minus h squared plus k. H and K is the vertex, and X equals H is the axis of symmetry. So the vertex form of a quadratic automatically gives us two things. Automatically gives us the axis of symmetry, and it automatically gives us the vertex. We don't have to use the axis of symmetry formula, x equals negative b divided by 2a, to find this, so it's less work. Okay, getting started, the axis of symmetry. Now, one thing you have to be careful about is this negative h. So, if you plug in a negative, it's going to make it positive. If you plug in a positive, it's going to make it negative. And so when we're pulling things out of this equation, you have to go in reverse. Since this is x plus 4 squared, then I know the axis of symmetry is at negative 4. Because if I were to plug negative 4 in here, negative 4 minus negative 4 would become plus. So I know how they got that. Okay. Sorry, I get excited about this stuff. All right. The y value does not change. Okay, so it was not plugged into a negative, so it didn't change signs. So the vertex is at negative 4, negative 2. All right, number 2, the value inside the parentheses is negative, which means that it was positive when it went in. And since there is no k outside, that means k is 0. So the vertex is at 3, 0. Number 3, the number inside the parentheses is negative. So that means it was positive when it went in. And the vertex is at 5, negative 4. And lastly, number 4. Okay, so this one is in standard form. We still know how to find the axis of symmetry with that. That's negative b divided by 2a. So this would be, there's no b. B is 0, right? There's no middle term. So x is 0. And if x is 0, that usually cancels everything out. And the vertex is at 0, 3. All right, so here we go. Number 5, graph each equation using a table of values. Identify the axis of symmetry, vertex, domain, and range. So you'll still want to use your calculator and use your y equals to put these equations in and get the y values. Maybe not while I'm doing the notes for you, but perhaps in the homework. So it would be very good for you to practice this a couple times at least before you do the homework. So axis of symmetry. The value inside the parentheses is positive, so I know it was negative when it went in. So that means the number in the middle is -2, and 2 points to the left and 2 points to the right. The vertex, this is my other coordinate for the vertex, this is 7, so the vertex is at -2, 7. Okay, now plug in this equation to your y equals, go to second table, and look at the values that are associated with these inputs. So for -4, it's 3. For -3, it's 6, and then this reflects over the vertex. So I'm going to go ahead and graph these points, -2, 7, -3, 6, -1, 6, -4, 3, 0, 3. Okay. Graph opens down because A is negative. Remember, this still has A, it's just out in front of the parentheses. So A is -1, which means the graph opens down. The domain of quadratics is always all real numbers. And the range looks like the y values start here at y equals 7. And they go down forever to infinity. So since it goes down, its y is less than or equal to 7. Okay. And that's it. That's number 5. All right, number 6, axis of symmetry. X equals, this is negative, so I know it went in as a positive. There's nothing outside for the y value. That means it's 0. So the vertex is at 1, 0. Right there. And 2 points to the left, that's 0, -1. 2 points to the right, that's 2, 3. Go to your table, put this equation into your calculator and your y equals, hit second table, and look at these x values. What are the y values that are associated with them? 12 and 3, and then they reflect 3 and 12. Okay, so we're going to go ahead and graph the rest of these. 0, 3, 1, 3. -1, 12, which is way off the graph. Okay, so these are the only 3 points I have on the graph. And you can see this has been stretched, right? So A is 3. And so since A is 3, this graph is much skinnier than this previous graph. Okay, and that's why. All right, domain is always all real numbers for quadratics. This graph starts at y equals 0, and it goes up forever to infinity. So since it goes up, its y is greater than or equal to 0. And that's it, guys. Graphing in vertex form. I told you it's easier. All right, so now, vertex form also reveals transformations. Okay, the most simplistic quadratic equation is y equals x squared. This is known as the parent function. Okay, and everything we do to this parent function affects it. Sometimes, as you saw before, graphs can be stretched or compressed, and they can also be shifted. They can be shifted left or right and up or down. A transformation is a change to the size or position of a figure. Okay, so you can see on these graphs is the parent function. This is the parent function already graphed, okay? The vertex is at 0, 0, points at 1, 1, 0, or -1, 1, and points at 2, 4, -2, 4. All right, so we're gonna graph these vertex form equations, and then we're going to tell the transformation. It says graph each function, describe how it compares to the parent function shown on the graph, okay? So y equals x plus 2 squared. So that means remember, if it's positive in here, it was negative when it went in. And there's nothing out here for the y, so that's 0. 2 points to the left. So this is -3, -4. 2 points to the right, -1, 0. Put that equation into your y equals. Look at the table. you should see that -4 has a y value of 4, -3 has a y value of 1, and then that reflects over the vertex. So let's go ahead and plot this. So we have -2, 0, -3, 1, 1, 1, 0, 4, -4, 4. Okay. All right, so we're comparing the graph. Well, what happened? It looks like the graph shifted left. And it shifted left exactly 2 places. So the transformation was left 2. Left 2 what? You can put units. Okay, just standard. Left 2 units. So to compare our functions, y equals x squared and y equals x plus 2 squared, when something is being added to x inside the parentheses, it shifts left. Okay, let's remember that. Number 8, x squared plus 5. Well, if there's nothing inside the parentheses, then that means my x value for the axis of symmetry is 0. 2 points to the right, 2 points to the left. So my axis of symmetry is at 0, 5. Okay. Just to show you how I got 0, this says x squared. It doesn't say x plus something squared or x minus something squared. Since it just says x squared, I knew that the x value for the axis of symmetry was 0. Okay. All right. So go to your calculator, put this in your y equals, go to the table. When x is -2, y is 9. When x is -1, y is 6. And then that reflects. Okay, so I'm going to graph this new point, 0, 5. 1, 2, 3, 4, 5. There's my vertex. 1, 6, and -1, 6. And those are the only 3 points on the actual coordinate plane. Okay, so I can go ahead and graph this. And what happened? Well, it looks like this time the graph shifted up. How many did it shift up? 1, 2, 3, 4, 5. So this graph shifted up 5 units. And I want you to notice when something is being added right out here, outside the parentheses, the graph shifts up. Okay. Wonder what it does when something's being subtracted. All right, number 9. Value inside the parentheses is +1. I know that for that to have been +1, it had to go in as a negative. So the axis of symmetry is -1, and the y value is -6. 2 points to the left would be -2, -3. 2 points to the right would be 0, 1. And if I put this equation into my y equals on my calculator and look at the table, the values associated with these are -2 and -5, and then that reflects -5, -2. And I can go ahead and graph my new parabola, -1, -6, 0, -5, -2, -5, 1, -2, -3, -2. Okay, and draw my new parabola. So what happened? Let's see. It looks like it shifted left 1 and then down a bunch. So it shifted left 1 and down 1, 2, 3, 4, 5, 6. Okay. So the transformation that happened was left 1 unit, down 6 units. All right, so when something is added to x in parentheses, it shifts the graph left. When something is subtracted outside the parentheses, it shifts the graph down. All right, last example on this page. Inside the parentheses, we have -4, so that means it was a positive when it went in. And outside the parentheses, we have +1, which is the y value for the vertex. So our vertex is at 4, 1. 2 points to the left are 3 and 2, and 5 and 6 to the right. Put this equation into your calculator, look at the table, and you should see the y values associated here are -3, 0, and that reflects 0, -3. Let's go ahead and graph this parabola. We have the vertex is now at 4, 1. And then we have points at 3, 0, and 5, 0, and 6, -3, and 2, -3. So this graph is opening down, which makes sense because A is negative, right? We have that negative out there. So how did this graph change? Well, it changed in 3 ways, right? Now the graph isn't opening up, it's opening down. So it flipped. Okay? This is a flip, or sometimes we can call this a reflection. Okay, you might see either one of those terms. And then let's follow the vertex. Okay, the vertex went up 1, and then right 1, 2, 3, 4. So up 1 unit, and then right 4 units. So makes sense. If you're subtracting from x in parentheses, it's going to move it right. And if you're adding outside the parentheses, it's going to move it up. All right, let's keep going. A few more examples and we're done. Number 11 and 12. Number 11, let's see, nothing is being added or subtracted to x in parentheses, so that's 0. Vertex is at 0, -7. 2 points to the left are -1, -2, and 1, 2 is to the right. Put this equation into your calculator. Look at the table. The values associated are 5 and -4. And that reflects over the axis of symmetry. So let's go ahead and graph our new graph. We have 0, -7 as the vertex. 1, -4, -1, -4, and then 2, 5. 2, 1, 2, 3, 4, 5, and -3, 5. Okay, oh, no. Should have been right there. Okay. All right, so if I connect these, you can see that this graph is much skinnier than the previous graph. So we have that 3 as our A, and anytime A is greater than 1, we know now that it stretches the graph vertically. And so this would be a stretch of the graph. So we're comparing it to our original. So this graph is stretched, and it's also shifted down. Let's follow that vertex. 1, 2, 3, 4, 5, 6, 7 units. So down 7 units. Okay. All right, number 12. Inside the parentheses, we have -3, which means it was positive when it went in. And then we have -2 outside the parentheses. 2 points to the left are 2 and 1. To the right are 4 and 5. Go ahead and put this equation into your calculator. Look at the table. Find the corresponding y values. We have -4, -2.5, and then that reflects, so -2.5, -4. Let's go ahead and graph our new function and our new equation and compare. 3, -2 is right there. Okay. 2, -2.5 is right there. And 4, -2.5 is right there. 5, -4. And then 1, -4. Okay. Connect the dots. All right, so what's happened? Well, I do notice just the graph is wider, okay? So this would be we would call this either a compression, not a stretch, a compression, and it's like it's being squished between between two flat bars, right? We have a bar on top, we have a bar on bottom, and they are just pushing down and up on this graph and squishing it, right? That's a compression. And that happens when A is between 0 and 1. So here A is 1/2, and that means that it's a compression, okay? Since A is also negative, that means, and you can tell here, that the graph flipped, okay, or it was reflected. And then let's follow the vertex, okay? And get rid of my line there. And the vertex went from 0, 0 to 3, -2. So that is right 3 units and down 2 units. So when 3 is being subtracted from x, it shifted the graph right, and then 2 is being subtracted outside the parentheses, it shifted the graph down. So let's put it all together and define some of these transformations. Given a quadratic equation in the vertex form, y equals a times x minus h squared plus k, h is the horizontal shift, and if it's added, it shifts left, and if it's subtracted, it shifts right. That's kind of counterintuitive, right? You would think if you subtracted, it would move to the left, and if you added, it moves to the right, but it's not the case, so be careful with that. When you're moving left and right, remember it's the opposite. And then K is the vertical shift. And if you're adding, it shifts up. And if you're subtracting, it shifts down. So this one is the one that makes sense. Vertical shifts make sense, okay? If A is negative, the function is reflected or flipped over the x-axis. And if A is greater than 1, the absolute value of A, it's very important because sometimes it can be negative. If A is greater than 1, then it is stretched. Okay, so it becomes skinny. And if A is between 0 and 1, like it was here in number 12, it is compressed. Okay, so we're compressing that parent function. All right, so it says transformations from the parent function y equals x squared are described below. Write an equation to represent the function. So I can use all this information that I just got and the previous examples to write equations in vertex form based on the transformations. So we start out with y equals, and this one was translated 2 units to the right. Okay, 2 units to the right is x minus 2 squared. Okay, translated 5 units up, that's y equals x squared plus 5. Translated 3 units left and 4 units down, y equals x plus 3 squared minus 4. Translated 7 units right and 4 units up, that is x minus 7 squared. Oh, gotta get my y equals in there. And 4 units up, that's plus 4. Reflected over the x-axis, then translated 3 units down. That's y equals -1, or just negative, x, oh, let me go back. I don't need parentheses. -1 x squared, and then 3 units down is minus 3. Number 18, reflected over the x-axis, then translated 5 units right and 2 units down. Okay, y equals -1 x minus 5 squared minus 2. So remember, anything that's left or right is opposite. So if we're going right, it's minus 5. If we're going down, it's minus 2. Number 19, vertically compressed by a factor of 1/3, so y equals 1/3, then translated 8 units up, 1/3 x squared plus 8. And then number 20, vertically stretched by a factor of 2, so y equals 2, reflected over the x-axis, so that means it's -2, and then translated 4 units left, that's x plus 4 squared. No vertical shifts. And that is the last problem. I am your teacher. This is the way. Boom shakalaka.